Its central goal of AI is the design of agents that can learn to achieve increasingly complex behavior over time. An important aspect of this is the accumulation of procedural knowledge about how to do things. Such knowledge allows an agent to abstract away from low-level motor control and learn and plan at a higher level. In this video, we describe a robot system that acquires skills autonomously in the process of learning to solve a task. We also demonstrate that the robot can use its acquired skills to improve its ability to solve a second task. We use the U-Bot5, a dynamically balancing 13 degree of freedom mobile manipulator, as our robot platform. Our experiment proceeds as follows. First, we set the U-Bot a task that it must learn to solve using a set of innate controllers. Once it has learned to solve the task, the U-Bot automatically segments its solution into a set of skills. These skills are added to its available controllers. Finally, we set the U-Bot a second task and compare its performance with and without access to the skills it acquired from the first task. We expect that the acquired skills will enable the U-Bot to solve the second problem faster. In the first task, we place the U-Bot in a room with 3 objects and a door. The robot must unlock the door by pressing a button and then open it by pulling a handle. This allows it to reach a switch. Pushing the switch completes the task. The robot interacts with the task to build a model of it as a Markov decision process, and then learns using real-time dynamic programming over its constructed model. The U-Bot needs 5 episodes of learning in order to acquire the optimal policy for the first task. These episodes are shown in the upper right of the video. The innate controllers given to the U-Bot allow it to navigate to an object or through a door, and once it is facing an object, to extend its hand and move it left, right, up, down or outwards. It can, for example, press the button by navigating to it, extending its hand and moving it forward. We use augmented reality tags or AR tags to mark the important places in the room so that the robot can localize them using a visual scan. You can see the view from the robot's cameras in the lower left of your video. Once the U-Bot has found the optimal policy, it automatically segments it into component skills. An appropriate abstraction is identified for each skill so that each skill's policy is defined using only relevant object and motor variables. The U-Bot acquires skills to press the button, pull the lever, and push the switch. The U-Bot retains manipulation skills, those involving its hand, because these can be reused in new tasks. Now we set the U-Bot a second task in a new room. Here it must unlock the door by pushing a switch and then open it by pushing a button. This allows it access to a handle. Pulling the handle closes the door, revealing a second button. Pushing that button completes the task. We compare the performance of the robot with acquired skills to its performance using only innate controllers. When using only innate controllers, the U-Bot must learn to sequence its manipulation actions each time it interacts with an object. By contrast, its acquired skills enable the U-Bot to immediately interact with the objects that it has already encountered in the first task. While the robot has the capacity to learn to solve the second task using only innate skills, it must do so using a systematic and laborious trial and error learning process. When using acquired skills, the robot learns effectively at a higher level. Because sequences of manipulation actions have previously proven useful in solving a problem, the robot has retained them, and so it can now execute actions like pushing the button by making only a single action selection decision. This greatly reduces the complexity of solving the second task. When we compare the time required by the U-Bot to complete its first trial in the second task, we see that using the acquired skills, in red, roughly halves the mean time the robot requires when using only its innate skills, in blue. This difference is statistically significant. To summarize, we have demonstrated a robot system able to autonomously acquire skills and thereby improve its ability to solve new problems. Thank you.